This section focuses on the problems of torus. This is an analysis of a structure of some members, as you can see in the video. In the video, you see that some members are put together. This is a typical torus structure. These members are held together, which means they are joined together. A torus is a structure in which the members are joined together as the structure shown in the video. The structure is composed by triangular parts. The members are assembled together at the points releasing the rotation. They are connected so that the rotation is free at these points. A triangle, although the members rotate freely, does not collapse, while a square does. So, this structure is recognized as a rigid structure. The figure below is a torus bridge. Those who have not learned about torus before may not notice this bridge is exploiting the characteristics of the torus structure introduced above. You may notice that this structure includes a lot of triangles to form a bridge. A bridge that is composed by such triangle structure with freely rotating joints is called torus bridge. We noted that this structure of members connected at rotation-free joints is defined as a torus. Let me introduce a little bit about additional information. If the members in the structure are firmly fixed, where the members are not free to rotate and do not tilt, this structure is defined as a ramen structure. Problems with ramen structures are a little more difficult to solve. This is because moments are generated at the fixed connecting points. So, in this class, we focus only on the torus. Basically, one may understand a torus problem as an expansion of the problems related to tension and compression of bars into two-dimensional. Problems of 3D toruses is not very common. In a typical torus problem, we analyze the behavior of a torus in a plane. Here, we assume that the deformations of the members, such as tension and compression, occurs in the plane direction. A member that composes a torus is a two-dimensional structure. At the joint of the member, it is subjected to two loads, one in the x and the other in the y direction, or one in the horizontal and one in the vertical direction, and it is deformed in the x and y directions, or in the horizontal and in the vertical direction. For example, in a simple torus problem, we analyze a structure where only one load is acting on the structure in a plane. Torus problems are related to the problems of tension and compression of bars that we have seen before. So, the torus problems are also categorized into statically determinate problems and statically indeterminate problems. We are taking this point into consideration when solving problems. In a statically determinate problem, you can directly determine the loads applied to the members and then derive the stresses generated. In a statically indeterminate problem, you cannot directly get the laws. So, laws are defined as unknown first, and then they are derived exploiting deformation conditions. Similar procedures are applied to the truss problems. So, you may compare the procedure with the case of bars subjected to tension and compression to deepen your understanding.